In this segment, we're going to take a look at the Python code that's inside of our umbrella stand. And so this code I actually got right off of a website, and it was a code called Rain Notifier, and it came from Dexter Industries. It can be said that there's nothing new in this world, and we are using the Dexter Industries GroovePy. That really helps us get through a lot of these things really quick without too much soldering. And so when we're into some quick and rapid prototyping, it's good to be able to take some existing code and then change it. And so I'm going to walk you through right now what we do have for the code on this. Let's take a look at the code that I borrowed and modified from Dexter Industries' Rain Notifier script. There's only a few things you're going to need to enter in here to get this to work for you. The first is going to be your zip code. My zip code is 87740 in scenic Raton, New Mexico. Put in your zip code there to get the weather in your neck of the woods. And then we're going to need to put in your API key. If you remember, the API key was from Weather Underground, and if you go under the More tab and over to Weather API for Developers, you can quickly and easily grab that key right from your key settings. And this is a simple copy and paste to get that in there. You want to make sure that you enter it correctly, otherwise it's going to return an error. There we go. After that, we have to set the delay on how often we're actually going to pull Weather Underground. I told you there was a limit, and that's 500 pulls per day. Right here I have the delay set for 5 minutes. Since the delays are set in seconds, I'm just doing a quick equation of 5 times 60 in order to get the 300 seconds, which equals 5 minutes. If you wanted to poll every 10 minutes, you would change that 5 to a 10, and vice versa. I think for this tutorial, 5-minute polling is going to work out perfect. The next step is to set whether you prefer to work in the metric or the imperial system. You're going to use 1 for the metric system or 0 for the imperial system. This is going to be important for this very next line here in determining the rain threshold. The rain threshold is how much rain you're willing to accept before you want the umbrella stand to let you know to grab the umbrella. In New Mexico, we don't get very much rain, so my rain threshold is 0. Since I'm using the imperial system, that's going to be returning a query from Weather Underground in inches. If you were using the metric system and this was set to 1, then this would return your query in millimeters. And that all depends on your preference. Now we're going to scroll down to the proximity. We don't have a choice here on whether or not we can use the imperial or the metric system. This only will use centimeters. This proximity will define how close your umbrella stand is to an active walkway. My umbrella stand is about 2 feet from the door. So if I say 60 centimeters, that's roughly 2 feet. Now, if any activity happens within that 60 centimeters, it's going to trigger the proximity sensor. We've set all our definitions up, and it's time to just let the GroovePy know where we're connecting all the sensors to. In this case, the rain LED is connected to D7, the ultrasonic ranger is connected to D4, and the buzzer is connected to D8. You can change these to any of the D pins on the GroovePy. I've chosen these simply because of how well it lays out. Once you've set all this up, you don't need to modify anything below this line. From here on, the Python script takes all these settings, it queries Weather Underground, it checks for rain, it'll check for proximity of motion to the umbrella stand, it'll turn on an LED, and then it'll also turn on a buzzer if someone's walking out the door or walking past the umbrella stand. I'm going to keep scrolling and just give you some quick explanations of what's going on in the script that we've put down here. We've got a bunch of imports here, which we always see at the start of a Python script. These are your standard imports for what this program is going to need in order to run properly. We're doing a digital write on both the buzzer and the rain LED to 0, which means at the start of this, we're making sure it's off. And then we're going to set some definitions. We're going to assign rain to status. And if that status is true, then we're expecting there to be rain, and the LED on the umbrella stand will blink. Else, if there is no rain in the forecast, then we're going to make sure that that rain LED is off. Now this time sleep uses that delay we set 5 times 60, so every 5 minutes is going to query again to see if there's any change in the weather. The next definition is for the LED. So if the status was true, we're telling the LED to blink. The reason I want the LED to blink is twofold. The first part is because a blinking LED is a lot more noticeable than a solid one. And the second part is because this is going to create a loop. And within that loop, I'm going to be using the rangefinder in order to see if there's anybody within proximity to the umbrella stand. We know if the LED is blinking that we're expecting rain. And in that case, if somebody is walking by the umbrella stand, I want the buzzer to go off. Also, because this loop will continue for the count that we set, and that count is dependent upon the delay, every 5 minutes this will reset when we query again Weather Underground to see if there's any change in the weather. Once we've set our definitions, then we're going to work to grab the API from Weather Underground. And this is the URL we were taking a look at earlier on. If you remember, when we were doing documentation, it gave us a URL that would allow us to use our API key in a certain location. So we're just going to go to this address, and I want to show you what this looks like. So right now it's set to San Francisco, and we could easily change that to our own zip code, which is what's happening. So this is the information that's being pulled now into the program. Going back into that, we can see how that's being used. So that's our API key. That's the zip code we entered. These right here are just defining what the sensors are doing. The Ranger is an input, meaning we're pulling in information from it, and we're sending that information out to a buzzer. And the Rain LED is an output. We're pulling information in from the Weather Underground API, and we're outputting that to the Rain LED. Now, the Ranger and the buzzer are dependent upon the Rain LED and the little loop that we set up here. This little bit of code here is just a simple test that's running through in order to make sure that everything is working properly. And if it's not, it's going to interrupt this and get us out of the program. And that's just so that while you are programming this, you don't get stuck in a loop. This is all the code that we are using in order to determine whether or not it's going to rain. What's happening at the very top here is we're opening that URL that we defined up here. And we are grabbing the information that we saw in the JSON string, which is right here. From that information, it's going to look at the current observation. If our metric is set to 0, it's going to grab the current observation in inches. Taking a look at the current observation in Raton, New Mexico, we'll see that precip today is 0.00. It's not going to rain. Now that we know it's not going to rain, we can actually use that equation, precip today, and say that if it is greater than what we put in for our rain threshold, then we're going to print rain today, take an umbrella, just to give us an indication that the program is running, and we're going to assign rain to true. Else, we're going to print no rain today and assign rain to false. That assignment then comes up here and gives us our status. And that's where we get is if true, blink the LED. If the LED is blinking, operate the proximity sensor to the distance we set and buzz if someone's walking by. Now we're going to have two indications. We're going to have a blinking LED if it's raining, and if you walk by and you forget to look over at the umbrella stand, it's going to beep at you. The only other bit here is just the keyboard interrupt, and that I use mostly for programming. It's worth keeping in there just in case you need to get out of the program quickly and easily. From here, it's just a simple matter of setting it up on the Raspberry Pi, running a few tests, and then setting it up to automatically load whenever the Raspberry Pi is on. That way it can be a headless state. We'll throw it into our umbrella stand and we'll check it out from there.